Okay, this is the first practice that I'm going to do, and is the control of turn and velocity of a DC motor using pulse width modulation. Okay, this system is consists of AT-MEGA 1284P, an oscilloscope, and an H-bridge with a DC motor. The code that I used was this. First, I declare the variables, the libraries, and here I establish a time, in this case the 10 seconds, that is the total in time in milliseconds divided by the period that I have, that is my ID number. In my case is 184, and here 20% we have to multiply here, and here is the cycle. Here I activate the motor in the port A, all the port A as an output, and then I activate the turn to the right of the motor, and I do the cycle of 20%. And here also I stop the motor. We can see here that the port A0, that is no port is activated, and here also to the left 4 seconds. So I divided my period and the time, total time of the duration in milliseconds. Finally, we stop another, and here I do a 2 cycles while. The first is a while with 9 velocities, and each velocity I put the duration of 3 seconds. This is the formula to know the duty cycle of the motor. That is 184 multiplied by I here, multiply 0.1, and here I'm going to have the duty cycle, that is this, and the duty cycle in low, that is the subtraction of 184 minus B. And here I zoom another cycle, so we're going to see that. And here I increment another duty cycle. I put the 10 velocities, increments of 10%, and here I continue indefinitely the last part, that is when the motor is high. Okay, now we're going to see it here. First, the 10 seconds to the right, as you can see, is a duty cycle of 20% of the signal, so the motor is turning a little left. Now the motor stopped for 2 seconds, and now the motor is turning to the left 4 seconds, stop again, and finally the increment of velocities. We can see the signal is augmenting here. Every 3 seconds I augmented the signal in a 10% duty cycle. You can see the signal is increasing to arrive to the cycle of 1%, 100%. Here we have, and that's all. Now in this practice I am going to explain how to control a servo motor using an AT-MEGA 1284P. The code is here. Here first I declare the variables, I put the libraries that I did before. Then I put this in a cycle while, which means that it will repeat all the port A as an output. And here I do the angles that it allows on the practice. First, I'm the angle 0. I do a configuration. I do my period is 184, but I put to 10% to 20% to the 0 of 1 to 180, and I put this relation, and well, I do this. I calculate the periods for high and low, for 0, 95, 18, 84. Now here I put the servo on 0 to start here. That is the positions. I do this with a while, and that if the letter I is different to 181, it's going to stay here. And here is the cycles that is going to do. So in 200 milliseconds, I do the change of position, and the position is defined by here, 18.4 that is in 0 plus 18.4 divided 180 multiplied by 1 to know the duty of each degree. And here is going to do the evaluation in high and in low. So here to do another cycle, to know how many cycles the program needs to do, I do this division. Once it finish, it increment the position. So now another position of the servo is going to do here. And to move to 180 to 0, I put this. That is the same, but here I enter with 36.8, that is the 180 degrees of the motor, and I do a subtraction here instead of addition like here. And now here is the same. I put the duty cycles in high and low, so the motor can come back. And here I just restart and increment the position as the same the code that I do here, but now backwards. So I'm going to show you how it works. Okay, first we start in 0. Now 95 degrees, 18, 84, and here's going to start to doing the positions and doing the turn to 180 degrees. Here I put the duty cycles to 10 to 20%. So the motor is kind of slow, but we can see that eventually it's going to reach to the 180, and when it reaches to 180, then it will restart the count and go back to 0. As we can see, we have here the port A as an output in the position 1. So now the motor is turning back. And well, here I put the motor to configure it to 180 to 0, and I just configure the PWM to 10 to 20% is equal to 0 to 180 degrees, and here I just make the calculations to know every position of the servo motor. It's just like proportionality between the two conditions, and here it stops and it starts again. So that's all.